Hello everyone, this is Khalid, and in today's video we are going to tackle another legal question called binary tree level order traversal. So from the name of the problem we can anticipate that we are most probably going to use BFS algorithm in order to solve this problem. So without any further ado, let's jump into the problem. So the problem statement says that we are given the root of a binary tree. Return the level order traversal of its nodes values. So, looking at the example 1, we are given that tree and we are supposed to scan these values level by level from left to right. So the output gonna look like 3, 9, 20, 15 and 7. And also we have here an edge case in case the tree is empty. We are gonna return an empty array. So in order to implement the breadth first search algorithm, we are gonna initialize a queue data structure. So the queue, we are gonna initialize it by the root of that tree. So the root of that tree is 3. After that, we are gonna implement a while loop that's gonna execute whenever there is a value in that queue. So whenever the size of that queue is more than greater than 0, we're gonna execute that while loop, the outer while loop. So first of all, we have to store the length of that queue. In this case, it is 1. It is 1. And after that, we will push the values of these that is already in the queue. So in the first iteration, we're gonna push 3. So we have to initialize another array, which is result, and in this array we are gonna push 3. After that, we have to initialize another while loop, the inner while loop, and in this while loop we have to check the length of that queue. So in this case it is 1, so we are gonna execute this bunch of code in only one time. So so the logic inside this while loop gonna be we are going to shift off the first value in the queue, which is 3, and we are going gonna push the left and the right value nodes in that tree. So we are gonna push 9 and 20. So now we will exit from the inner while loop, and we will again execute the outer while loop since the queue is not empty. So again, we will set the length of that queue, which is 2 in this iteration, and we will visit again the inner while loop, which is we're gonna execute that code 2 times since the length is 2. So we are gonna again shift off the first value, and we are gonna see if that value has a left and right nodes. No, it does not. So we will just shift it off from the tree, from the queue, and for the 20 it has left and right values, so we are gonna shift it off and again push this value into the queue. 7. So again we will reinitialize the length variable, which is in this case also it is 2, and we will execute this inner while loop twice. So we will push that off. We will shift that off from the queue, and it does not have any left and right values, so we are gonna just shift it off, and same also for the right node. So now the queue is empty, so we are gonna exit from the outer while loop, and we are gonna return the result, which after pushing all these values will get the 9, 20, and the 15 and 7. So I hope that the logic is clear. Now let's jump into the code. So first of all, I will check that each case. So the way of doing that is, if we don't have any value in the root, we will return the empty array. Now I will initialize the queue, and we will initialize it by the root of that tree. And also I will initialize the result array that's gonna store the final result. It will be initially an empty array. So now let's implement the outer while loop, while queue.length. As long as there is a value in that queue, I will execute this logic. So as we said, we will store the length of that queue.length, and I will push the values inside that queue to the result array. So result.push, and it's gonna queue. I will map over that array and node, and I will store the value of that element. So in the first iteration, I will end up with like this. This is the result, and this is gonna be 3, right? So now I will implement the inner while loop, which is gonna execute as long as the length is more than 1. Otherwise, it's gonna be a false value, which is 0. First thing, I have to shift off the first element in the queue. Let node equal queue.shift, and if in case there is a left node exists, I will push that to the queue.push node.left, and also the same logic here for the right node. So after executing these 2 while loops, I am gonna end with the result array. So I have to return that result. So let's test that out. So everything worked correctly. Let's verify that by submitting it. I hope you enjoyed this video. See you in the next one.